Good evening. Welcome to SCI-Arc. Architecture moves, not the same as architecture rocks. That doesn't mean up or down. That doesn't mean forward and back. That doesn't mean left or right or better or worse. But the contents, the emphasis, the form language, and the means of representation continue to evolve. How does that happen? Who says what architecture is? Who says what architecture is? Tonight at SCI-Arc, we have someone who just might be a candidate. There are those who currently argue that the advance of technology assures the advance of architecture. The technology carries architecture forward. Does that make contemporary architecture the voice of the up-to-date? Mónica Ponce de León and Office DA offer a complex response. Theirs is an intellectually speculative practice, clearly distinct from the current software allegiances, which form a very different belief system. Office DA speculates on space. What's a wall? What's a roof? What's a floor? What's a window? And perhaps finally, what's a building? In the tradition of SCI-Arc, Mónica Ponce de León is intent on dismantling what's left of architecture's dictionary and offering us her own. Please welcome Mónica Ponce de León of Office DA to SCI-Arc.
You guys have no idea how excited I am to be here and how excited we are at the prospect of being here during the summer and actually teaching a studio here in the summer. I want to thank Eric Moss and Ming Fang for making it possible for me to be here today, but also for us actually being here during the entire summer. And I really want to thank Hilary Laux for being so patient with me and putting up with sort of my dizziness. If I could have the first two slides, or do I do that myself? These slides have gone through a lot today. Let me see. We have become what I'm going to do today is that I'm not going to show all projects in their entirety. I'm going to actually show you bits and fragments of our projects, and I'm going to concentrate on certain themes, and I will focus more in some and less in others. We have become interested in the idea of a constructional tolerance, meaning what does it mean to build a building with zero tolerance? How does one actually achieve precision or the image of precision? How is precision somehow present or absent in an architectural project? And we have taken, in some cases, this to an extreme. We've become obsessed with economy of means, whatever that may mean. And again, with the lack of relationship between economy of means and how that becomes represented. Now, more importantly, we have become interested in the idea of alibis. how to come up with alibis for making choices, how to come up with alibis for making form, how to come up with alibis for simply making a building. And the word alibi for me is very important, because alibi may, as you know, when you are accused of a crime, they ask you if you have an alibi for the time of the crime. Now, you may be telling the truth, or you may actually be saying a lie. So alibi could be both truth or lie. And this ambiguity between innocence and guilt is something that we find very potent. So we use program, site, and technology, digital or otherwise, as alibis for the production of architecture. And I'm going to start with very, very small projects. These are simple file cabinets for the Graduate School of Design at the GSD. We were asked to, very generously, we were assigned to redesign the second floor and the third floor architecture and urban design offices. And we simply did an interior design project. We left the building as it was, and we just simply brought in furniture. And we became fascinated with the idea of designing furniture as topographies, and using the grain of the wood as something that will resist or would inform the topography itself. Okay. Oops. Let me see. So on the left-hand side, you can see a CNC routed file cabinet where the plywood is actually parallel to the CNC. So we're actually excavating through layers of plywood, and each of the layers becomes a topographic field. Whereas on the left-hand side, we're excavating against end-grain plywood. So the lines of the plywood, the artificial line of the plywood, becomes a register against which the curvature operates. In both cases, however, the handle, the act of opening the drawer, became for us an excuse for the rippling effect in either one of these drawers. Now, I'm not always going to change both slides at the same time. Do you know how I can do that with the changers? Well, right now I push just one and both change. Okay. So in this case, the CNC router actually produces a handmade effect. So there's a contradiction between the effect that is produced and the technology that was used to generate it. Yeah, this is not working, I'm sorry. I want to go back on the left-hand side. No, go forward. All right. Yeah, this is not going to work. Oh, goodness. Can you go back one on the left? I think I'm just going to ask you to switch them. I'm sorry. All right. This is a dining table in which we were pursuing similar ideas. In this case, we were interested in the leg of the table becoming a single entity with the top of the table, creating a seamless relationship between them. Could you switch both? So we collaborated with both manufacturers so that we could actually produce a very light carbon fiber table where the top of the table becomes its leg. And we play with the idea of inside out, so that the top of the table becomes the inside of the leg, and the bottom of the table becomes the outside of the leg. Oh, goodness. Can you change on the right-hand side? All right. Now, this idea of seamlessness is something that we have also tested at the scale of a building. In this case, a house for a couple who wanted to retire in Bilbao, in Spain. And we have to thank Frank Gehry for allowing the clients to have a more open mind as to what a building should look like. In this case, we we played first with the idea of dissecting through the building, since we were against a hillside, and actually being able to occupy the top, the roof of the building. At the same time, all of the programs, again, because it was supposed to be a home for retiring, needed to be in a single floor plan. And what you see on the right-hand side is the floor plan with basically all of the programs. The dining room, which is the oval-shaped room, needed to accommodate a 19th century oval-shaped table. The living room needed to orient itself towards views, and then the library needed to have a requirement for how many books, for however many books they wanted. So we took each of the requirements as excuses, again, to produce a figuring plan that was not cohesive. And in fact, we like to argue that the plan can be read in many ways. As somehow being colliding within the plan. Now, most importantly, each of these rooms seems to put pressure on the skin of the building, almost as if the building was shrink-wrapped, the skin was shrink-wrapped around these rooms. So, for example, the moment in which you need to drain water and have access, a staircase to the roof, has a certain impact on the elevation. Now, buildings, of course, are not constructed out of saran wrap. So how does one translate this idea into a constructional technique? The clients asked us to work with a local sandstone, and you have an example of the sandstone on the right-hand side. And we became interested in this idea of buildings where the stone is actually embedded with other materials. And instead of wood, which is, of course, the sort of conventional, traditional technique, we began to work with laser-cut steel that would make up templates. It would make up shelves for the stone itself. So the jig that will guide the mason for the laying of the stone will become impregnated and embedded within the building. Oh, God. Can we change on the right-hand side? Back, I mean. And you begin to see in this image the horizontal lines of the steel sort of being a marker within the elevation. Now, depending on the economy, one can use a strategy for the whole building, or one has to focus on a particular aspect of a building. Working with a similar problem in America is actually a very different set of issues. So when we were thinking of this sort of technique of vacuum forming or, again, shrink wrapping, we couldn't take it to the scale of an entire building. It's just not financially feasible, at least for a firm like ours. And for a building in Green Bay, Wisconsin, we were given a site on a corner lot, which actually was very well positioned because it was in a main axis that connected a series of public buildings, and it connected back to a park and then to the river. For this particular project, we decided not to do the traditional thing that architects do with an end block. Instead of putting the stair on the party wall condition, since we had a very low budget and we had to invest money on the staircase, we said, okay, why don't we put the stair on the outside of the building? In that way, you focus all of your money into one, how do you call it, put all your eggs into one basket? So what you're looking at is a stair that connects a cafe and a gallery on the ground floor to an art studios in the upper floor. Now, this idea of having the side of the building in an end block condition not behave like a side is nothing new. I mean, there are many buildings in cities that decide to treat the side as if it was yet a third front. So in our case, that third front, that staircase, became the moment where we could actually investigate the possibility of distorting the building. And what you're looking at is a skin that somehow becomes imploded. so that it's like a sock inside out. It's not clear where the facade begins and where the facade ends. At the same time, the stair becomes a directional device, so that as you go up, it points you towards an existing landmark, a church, but as you're going down, it frames the view of a public space, a public park. Now, again, this was a very low budget project, so the rest of the building had to be relatively simple. So we decided to treat it almost like a warehouse, two-slab project with a twist, in that we used the excuse of bringing light to the gallery and bringing light to the cafe as a means of introducing two skylights that penetrated the building. But also you have to bring plumbing through the building up. So these two elements that are interpenetrating, one from the top and one from the bottom, became agents for activating the section, if anything, in a very modest way. So the distortion in the elevation, again, this moment of the sock turn inside out, was possible by accepting a very conventional method of fabrication, doing metal studs throughout the building, and then adapting the metal studs to the moment of the staircase, to the moment of the opening. So what you can see on the left-hand side is actually laser-cut steel fins that get laser-cut with the impression of the brick itself, so that the structure becomes, again, the jig for the placing of the masonry. And we reduced the size of the opening several times to be able to bring it within budget, and we reduced it as much as if it was possible before you kill the idea. If I could change only in the right-hand side, and then you place steel angles every third brick, just like you do in conventional construction. And then next slide. And then this is the wall with the brick already placed on top. Next, on the right-hand side. For the rest of the building, we relied on, again, very conventional constructional techniques, but we worked with the idea of making the brick seem thinner or thicker, load-bearing or not load-bearing throughout, so that in the same corner, you will have a fat wall and a skinny wall sitting on top of each other. Again, to sort of not favor one mode of construction or one reading of brick construction over another. And we did the same thing with the fenestration. So we're purposely always trying to have as many techniques and as many sort of interpretations overlaid on top of each other. Now, we got into this discussion in the office about the difference between shrink wrapping and vacuum packing. And I'm not sure that I know the difference still. And there is different sort of camps in the office as to what one means versus what the other one means. But in general, there is consensus within the office that this is not shrink wrapping, that this is vacuum packing. And as it has been explained to me, the difference is that in this case, one takes what would have otherwise been wasted space and one sucks it out of the building as a means of gaining something else, as opposed to taking figures and then wrapping them with saran wrap. So in this case, I have sort of two diagrams that will help explain our next project, in which, let's say, this example of the stair, which is an easy one. You take out the underneath of the stair and you make it usable, wherever there is headroom. We were having these discussions in the office about the difference between one method and another when we were commissioned by a group of artists outside of Beijing in China and art dealer in New York to do an art center in an art colony called Tongxian, which is southeast of Beijing. And it's a very peculiar project because our clients are artists, and they have as a mode of working a respect for what a designer does that is very rare and is actually very refreshing. So whatever mistakes or whatever errors may happen in the project, I can't blame them on the client. You can only blame them on the architect. We were given, however, a very peculiar site, probably one of the weirdest sites I've ever encountered. We were given a site that was divided on one half, a beautiful wooded area, on the other half, this blighted zone. Across the street, ugly suburban homes, incredible to find in China, but also power lines that were crossing through the site itself. So we sort of grabbed onto the only thing that was on the site, which was a wall, an existing wall that divided sort of the pretty area from the ugly area. And we decided to place our building almost like a mothership against that wall and to puncture through the wall so that our building will become the bridge between the two halves of the site. We also took advantage of an existing alley of trees that could shield access to the site as you came in. And ultimately, the intention of the client is to actually build a series, to add more studios if the project is successful. And the idea will be, again, that our building becomes sort of the mothership for all of these studios. I think probably you guys can't read anything in the plan, but we're looking at a long gallery. On the plan, you're looking at a long gallery on the right-hand side, and then two artist studios. One of the artist studios has a bedroom on the second floor, and the other artist studio has everything on the same level. And then on top of the artist studio that is the artist studio that is on the ground, there is a caretaker's apartment, and this will become important later. But in working with organizing the pieces of the project, gallery, two studios, caretaker, we became interested in producing a plan that could be understood as a single building that was chopped up, but also perhaps as three buildings that came together. And in fact, the construction documents were drawn as if it was three separate entities with some drawings that brought it together. And because of these slippages or this compactness of the elements, then this idea of pressing against the building and sort of forcing you to go through the cracks of the building became sort of the motivator for, again, our interest into vacuum packing, sorry. So, for example, as you go through the courtyard and you slip into the gallery, the building has to move away in order to allow you to go into the gallery. In all of these distortions, there was an incredible sort of pragmatic but absurd minimalism, where we would again squeeze in any inch that we could in order to gain circulation. So, for example, this is the main access into the courtyard that views towards the forest of trees. And on the right-hand side, you can see a stair that takes you to the caretaker's apartment. And you can see how we're distorting the wall as a means of being able to pass through and under the stair. Now, this, again, ambiguity between was this a single building that got split apart, or is this a building where things come together? Could I have focused on the left-hand side? Also has very specific, material repercussions. So as you're going through this crack, again, that connects one garden with the courtyard and the grid of trees or the forest, we were interested in developing the two walls as if they had once been one, or developing the two walls as if they could one day be one. Now, in some cases, the wall moves away to let you pass. In other cases, when the wall realizes that you're not going to pass, the wall moves over. So, for example, here the wall is moving away, but if you're going up, you don't need the headroom on top, so the wall moves in. So again, there's always this economy of space, where if a space is needed for passage, the interior of the building adapts to it. If no space is needed for a passage, then the interior of the building takes it over. And you will notice that there seems to be sort of a corbelling effect that the walls produce, but when you look at them in plan, and I know that they're very small, all of the coursings for the walls are actually straight in plan. So what we're doing is that we're rotating coursing by coursing in a straight line so that the mason can actually begin at one end and go straight to the other end. So we're going from a vertical point to a jig on the other side that guides the beginning and the ends of the coursings. In this case, because it's in China, labor is very economical, but we had to rely on very simple technology. Now, again, these displacements have an effect on what the brick coursing is doing and what the skin is doing. So when a wall displaces out, or when a wall is pushed in, either reading could apply. The Flemish bond has to give. The Flemish bond has to open. So while on the one hand, as a massing, you might read it as vacuum packing, what is happening to the skin contradicts this argument. Because while it reads as if you're pushing at the bottom, the pattern is actually telling you, no, you're stretching it at the top. So again, there is always a back and forth. So when you think you figured out the building, somehow we tell you, no, you haven't. On the second floor, we have, again, a bedroom that belongs to one of the studios looking down into the gallery, and we have the caretaker's apartment. And this sort of interpenetration in section from one studio to the gallery, the double heights of the studios, I mean, there's sort of an intertwining of staircases and volumes that, again, have a relationship and a back and forth with what the envelope of the building is doing. So while the skin is trying to contend with passages and movements, the roof has to contend with shedding of water, with bringing light into the art studios. And you can see how how these things need to be negotiated. So for example, on the slide on the right-hand side, you can see one roof dipping down over the staircase, whereas it dips down to allow light to go through the skylight, whereas the roof over the studio has to dip down in order to shed water. And again, these moves for us had counterparts in the way that we dealt with the brick coursing itself. This is, in the right-hand side, you can see sort of the negotiation between shedding of water of one roof and the light coming through. The gallery is actually an interesting case study. There is a staircase that connects the gallery to an office on the second floor, which you can see in this diagram. But there is also the problem of bringing light into the gallery itself. So the roof of the gallery, which is at the far right of the elevation, dips down to shed water, and it gives the gallery almost its object quality. If I could change the right-hand side. But at the same time, the roof has to lift up in order to allow as much light as possible within the gallery itself. So this distortion also has to negotiate the intersection with the bedroom coming from the other side of the building, and that's what produces this sort of roof landscape. yet one more technique in which, instead of stretching the bricks as a way of accommodating for the vacuum packing, in this case, the bricks are compressed as a way of accommodating for the vacuum packing. So the projects that I have shown, if I could have focus on the right-hand side, the projects that I have shown until now sort of negotiate the distinction or lack thereof between a program, its volume, and its skin. The projects that I'm going to show from now on focus on this idea of tolerance, whether one can actually negotiate the difference between structure, geometry, and a semi-perfect system, or a system that pretends to somehow be perfect. We designed recently a restaurant in Boston, which its claim to fame is that everybody says it's New York that came to Boston. I don't know if that's good. I'm hoping after this summer we design another restaurant and they'll say LA came to Boston. It gives you a sense of, design culture in Boston today. One of the challenges of the space had to do with smoking laws in Boston and how we needed to design a screen area for smoking. So we designed this sort of object that will sit on the space. It's this sort of rounded thing. I'm sorry I don't have a pointer. The rounded thing on the top of the plan and this sort of weird brown thing at the end of this photograph. And the request was, well, can you design something that is screen, but is visible, is porous, you can see through it, and so on and so forth. So the object had to somehow sit on the space but not look foreign. It had to be intimate but somehow still visible, and it had to sort of negotiate all of these, mundane things that one does when one is doing restaurant or commercial design. We thought that one strategy would be to use a single size unit, meaning that our bricks, which in this case are not brick but are actually made out of plywood, that our tectonic unit will be the same. Why? Because it's cheap, it's economical, it's easy to do. You tell the contractor, cut all of them the same size. And we thought of the of the sitting, of the back of a person as a module to work with, so that the act of sitting around this place was somehow registered within the structural system of the piece. So what you're looking at the right-hand side is an inverted, a worm's-eye axonometric of what we call the hookah den, or what the client calls the hookah den. And what you're looking at is each of the facets actually represents the back of the seat. So we did it so that couples that want to make out can sit sort of body to body, and people that don't like each other too much sit a little bit more distant, so that we sort of began to imply a certain sociology of the space. But in order for it to stand up, it has to go from, what worked as a gathering space, because it also had to work for a single event, a single party. If somebody wanted to rent it for 20 people, they should be able to. So it goes from this circular shape, which would have been unstable if we had just extruded it, to a more geometric, how would you say, stiffened, a stiffened structure through its geometric manipulation. So it crunches up, translation, it crunches up at the top. So what you're seeing here is that it's basically rounded at the bottom, and then the faceting of it at the top allows it to stand up. And I have to say, our first structural engineer said, this is not going to stand up, this is going to fall down, this is not going to work, you have to redesign it. We fired him. And we hired another structural engineer who said, this is no problem. And we've been working with him in every single project ever since then. It also helps his son goes to school, and his son has been a student of mine. So So one of the pressures of the piece is that it had to stand up, therefore the geometric manipulation. But another pressure on the piece is that it had to respond to existing conditions. We needed to locate it in the sort of the worst place on the restaurant, right in front of one of, right in front of one of the way stations and actually covering up the way station. The problem with that is that there is a soffit. And we also had to orient the door in a certain direction, which meant that the piece couldn't actually be concentrical. The piece actually had to distort. The door had to turn to the back, and the moment of highest crunching up had to be distorted from the center. Which meant that we couldn't just sort of design one ring and then the contractor set it back 3 inches thereafter or 2 inches thereafter. So instead, we printed out a plan of the dome at actual scale, and we had the contractor paste it on the ceiling. And I'm sorry I don't have images of this, but the plan at actual scale became the guide for 20,000 plumb lines, which the contractor then used to move in. And actually, the contractor thought that we were crazy, and the contractor said, "I'm not building this." But then the girl that drew this, a woman in my office that drew this, got really angry, and she said, "I can build this." She showed up in the site. I'm serious. She showed up in the site with a what do you call these things? A building belt, and she started building it. She went one by one, and she started building it. So she basically shamed the contractors who felt if this woman who has never even used a hammer before can build it, we certainly can. So they ended up finishing up the job. But she was so worried about quality that she wouldn't let them just build it by themselves. She had to be there when they were screwing anything. Which, I'm telling you the story a little bit because it's entertaining, but also because it sort of proves the difficulty of working within certain boundaries and how a certain level of precision or lack of precision forces you to go through those boundaries. It actually forced her to do something that something she was not trained to do, something that normally she wouldn't do. And it proves that things that look impossible may actually be possible. So unlike the first project that I showed, the file cabinets, this falls on the category of something that is digitally derived. The digital drawing became a jig for the construction of it, but it's actually built by hand. Whereas the first project I showed, the drawing is the object. Ouch. Could you change this side? Yeah. We were asked by the Museum of Modern Art to participate on an exhibition, and there were several museums that did the same thing at the same time, and we were one out of many participants in many teams. And this is actually one of our earliest pieces. It's an old project, but I brought it in because it is actually a moment, again, where the drawing becomes the actual thing. And also because it's a project in which we learn this sort of relationship between precision or tolerance. We were asked to do an installation in the garden of the museum. We decided to put it against the wall. On the one hand, because it produced a space underneath it, but also because it provided bleachers for sunbathing in the... Could we raise the image on the right-hand side? I'm sorry. No, could you just raise it? Yeah. Sorry. It allowed for sunbathing in the summer, and it became a billboard for the show on the street behind the museum. We work with laser cutting techniques that allowed us to do a multiplicity of things. It allowed us, for example, to perforate the metal in gradations, so that the bottom of the piece has less perforation, the top of the piece has more perforation, which makes sense in terms of structure. You want it to be light at the top, heavy at the bottom, but it also produces different effects as you move around it. We became interested then on using laser cutting as a way of bending metal, so that you wouldn't have to use a brake. You wouldn't have to break it and then get a radius as a result of the break itself. And we thought of maybe constructing the project not as post and beam, post and lintel system, which is usually how you associate metal, but instead of creating an ambiguous relationship between what is a beam and what is a column and what is the skin that ties them together. So the analogy that we were working with at the time is one of origami. What happens when you fold a surface and you give it a structural rigidity by its folding? Could we change the right-hand side? So by laser cutting on what is called a stitching pattern, one is actually able to bend steel. Next one, on the right-hand side. One is actually be able to bend steel to 90 degrees without any curvature. Can we have both? Which gave us incredible precision, because it meant that we could put two pieces together of metal and have them perfectly line up, which meant that we could do a piece of origami where the seams between them, the folds between them, were in perfect alignment. So on the right-hand side is the original drawing of the entire piece unfolded with many bands, what am I saying, 5 bands, that then gets folded together and then seamed together. And here on the left-hand side is the joint between two of those bands. We ended up making it at smaller bands because the fabricator had smaller steel on the factory that he could give us for free, and it was a very low budget project. So what you see on the right-hand side is one of the sheets that was laser cut. And in the left-hand side, you can see the different joints and joints that were created by wrapping one piece on top of the other. So, for example, you can see one folding and holding on to the next one. We designed the piece so that as you moved around that it changed dramatically in terms of its figure, becoming really, really thin on one end, becoming sort of fat and distorted in another one. And then for one point of view, the piece actually flattens, and you lose sense of its actual real dimension. This technique is, of course, being used before anamorphosis, which from one point of view, you get this sort of seemingly perfect figure, but as soon as you get out of that sort of idyllic moment, then you realize that the figure was not perfect at all. Now, more recently, we did a project competition entry for PS1 for the Urban Beach project. I don't know if you guys are familiar with this. We were asked by PS1 to submit a proposal for their garden, for their courtyard. And generally what they do is that they give the courtyard to the community as a summer beach. Let's see. Okay. So our proposal was to create a roof structure under which you had a bar, a water fountain, selling of fruits, and sort of chaos. On the other side, which is the rectangular shape next to the roof, we filled up a pit with sand. Could I change the left-hand side? No. No, go back. So the pit with sand became a very straightforward project in which we sort of filled up one corner more than the other. Next, again on this side. So that this became a way of framing the view of PS1 and looking back at PS1. And also a way of sunbathing, sort of a nicer way of sunbathing rather than laying sort of in a horizontal plane. Next on the left, and next on the right. Now, this canopy became sort of an all-encompassing roof, and we decided the program underneath should just take place. But at the same time, we thought that it should be some sort of organizing device. So for instance, we felt that it should come down towards the entry. The entry is on the right-hand side of the left slide, that sort of box opening. We felt that it should come down towards you as you enter, and that it should become some sort of a threshold. If I could switch both. So we started working with the idea of a Tensegrities structure, a structure that had members in tension and members in compression, because the walls couldn't take a heavy structural load. So if you do a Tensegrities structure, the structure stands on its own. It has its own structural logic, and only the weight of the structure will rest on the walls. The problem with a Tensegrities structure is that you have to triangulate and you have to do an offset grid. But at the same time, we wanted to have a lot of control over the grid, and we wanted it to, again, begin to manipulate space as you move through. And I'm sorry, these are very light, and if you could focus on the right-hand side. So the bottom image is sort of a regular grid that then becomes offset, and I'm sure you can see the red dots and the black dots, but believe me, they're there. And then on the right-hand side, you can see how the grid begins to become two layers. So you have a series of compressive members on a top layer, and then a series of compressive members on a bottom layer. So in this image, you begin to see how instead of just dropping them as two separate layers, which is what is normally done with Tensegrities structures, we decided to do a zipper structure. So that from one side of the space to the other, and then from the back to the front, the two layers sort of came together in a zipper fashion. If I could change the left-hand side. So from the right-hand side, from one side to the other, the canopy lifts up so that you can occupy it and sit underneath it, but also as a way of defining the bar area. So we had two moments, and we had two contradictory geometries. A geometry that lifted from back to front, and a geometry that lifted from side to side. And the top tier responded to one geometry, the back to front, and the bottom tier responded to the other geometry from side to side. So what you're looking at in these diagrams is the top tier and the bottom tier in plan. And what is happening is that we start with one stick being vertical, going to horizontal, and then one stick being horizontal, going to vertical. And then on the right-hand side, you get sort of the grouping of both systems and the contradictions between both systems. Now, each system in itself has a very specific, precise geometry. When you put them together, its precision is somehow diffuse, its precision is somehow lost, even though it's still obviously there. Now, here was the dilemma. We really didn't want to do another Tensegrities structure. We didn't want to do a high-tech cable with, with metal tube structure that, we've seen already for over 40 years. But the structural engineer was telling us you actually have to do one because you cannot put the weight of this canopy on the wall. So after much scratching our heads, we thought, okay, what if we take the logic of tensegrity, but we completely revisit its imagery? Meaning that instead of relying on cable and metal tubing, we begin to look for other materials that could perform the same way. And that took us to the most inexpensive material in the world, rope. All the rope for this project was about $1,000, which is unbelievable. Home Depot pricing. The other beauty of rope is that it would allow us to actually weave the piece together, rather than thinking of fastening or rather than thinking of joints through metal tubing. So we took on the existence of openings in the existing concrete walls, the openings from when the wall was cast. There is little circular holes in a concrete wall. You've seen them everywhere. It's a normal concrete wall. We took this as an opportunity of actually weaving through the holes, and this is an early version of how it might weave through, and it's a little rudimentary. And we didn't win the competition, so we're not going to get to develop it, unfortunately. But the idea being that this system, instead of just simply being the structure of the ceiling, could actually begin to invade the walls. And the other interesting aspect of rope, and this is the technique used for this chair on the right-hand side, and I apologize, I forgot the designer, is that you can dip it in resin and make it stiff, which meant that we could do our compressive members and our tensile members both out of rope. We played, I don't know where we would have fallen, I don't know how we would have ended up doing the project, but we played with the idea of making them the same thickness, or actually using different kinds of ropes, one thicker, one thinner, different kinds of weaves, maybe weaving the compressive members differently than the tensile members. But the intention would be that the same material could act in both ways by having it raw, but also by having it dipped in resin. Could you focus the right-hand side? Change on the left, and then change again. Okay, could you focus again? This is the last project. We were commissioned by a very young entrepreneur who wanted to open a pizzeria, a small pizzeria, in one of the most conservative streets in Boston, in Beacon Hill, in Charles Street and Beacon Hill. And the space is very, very small. We're talking about a space that half of it is kitchen, half of it is the dining / takeout. So what we did is that we placed a table in the center of the space for those people who didn't want to go eat it at home, for those people who wanted to eat it right there. And we sort of concentrated on making very simple moves. He needed, because it's a brand new place, it's not a place that is known, it's not a place that is a franchise, it's not a place that has history, he wanted something that would immediately call attention upon the space. So we started working with the idea of a wall that would become the billboard, or the sort of, it would announce the presence of the establishment to the street. And it would also sort of shock you as you walk by, because you're so conservative in the street that you never see anything like this. If you could focus on the right-hand side. In truth, the idea of the wall actually came from the ceiling. We walk in the space and the ceiling was a mess. It had the most sort of junky mechanical system that was servicing not only this space, but actually the entire building. And the landlord made it very clear that we could not move anything. So we began to work with an idea of, again, a very rational system so that we could hang it, so it could be hung easily. And the pattern that you see is something that was drawn on the ceiling very easily to identify points for hanging the ceiling. but also a system that began to respond to existing HVAC requirements. And again, I'm sorry I don't have a pointer, but hopefully you can see that there is moments where we cut through the ceiling. You can see it in this view as a way of allowing air supply, sprinklers, and all of this sort of paraphernalia to come through. And that determined actually the size of the geometry. As you move back, the openings needed to be bigger, so the diamonds are bigger. As you come forward, the openings needed to be smaller, therefore the diamonds are smaller. So while the geometry in plan is very rational, so you could, again, place the metal hangers, the conventional metal hangers to hang the ceiling, the existing mechanical system did not allow us to just simply do do a simple geometry. So there was a contradiction between the section and the plan. So whereas in the Museum of Modern Art, we artificially constructed an idealized view, in this case you can imagine the ceiling itself, the ceiling plan, the reflective plan, one that you can never see, but one that you need for construction as to be that artificially idealized view. And again, you can see the ceiling responding to the existing soffits, the existing HVAC, and so on. Now, because of this contradiction between a plan view and what was three-dimensionally possible, we turned to, in terms of constructional techniques, we turned to clothing manufacturing and clothing design as a way of understanding how can we actually produce these pieces. The pieces were made out of aluminum, and they were laser cut, they were laser cut, but their geometries was derived the same way that a seamstress will derive a pattern. And I'm only showing a few here so you can see. They're hung in 4 points, just like a conventional, ceiling tile. And each of the shapes is completely different from each other. This is something that is only possible because of laser cutting technology. So again, something that in reflective ceiling plan may seem as if it was perfect, in its execution, it proves that it cannot be perfect, that it can only be but distorted. But ironically, in its precision in order to produce that imperfect effect. Thank you. And I would love to take questions. Go ahead.
I wonder if you have a preferred method of working out your geometries, whether it was in physical model or drawing or a combination.
Good question. I don't think we've ever worked out a geometry in a physical model. We've used models as a way of figuring out how to build geometries, as a way of testing geometries, and then we go back and we revise or we change the geometry accordingly, but generally we develop it in drawing. Although there has been projects actually where it's been back and forth. I'm sorry, no, the Bilbao house actually was in model. We did it in drawing, we thought this is it. We built the model and it was horrible. So we actually had, and we was wrong actually. So we actually had to build the model, and then draw the model. So it actually goes back and forth. You had a question?
I was just curious about what you're talking about perfection. I think there's a lot of perfection that comes about the process of, control the process. And I'm just curious to what degree or kind of how you feel about that. Because to me, there's a certain way in which to work, but I guess what you're saying, you need a certain amount of precision to it. It's kind of calculating perfection, but also often
Yeah.
And I'm just curious if you allow for, or if there's any idea about allowing for the process itself to come into
That's a very good question. At the end of the day, there is so much. I mean, for me, that's not how. When I talk about imperfection, that's not what I mean. There's so much of that contractor-driven or mistake-driven imperfection out there in the world that to allow it to happen or to make it part of somebody's discourse is not something that we're so interested in. In a way, we, for better or for worse, we want to be stubborn about insisting that you can build well in America and that you can build things in America that are even better than anywhere else. So there's certain stubbornness. I mean, there's a lot of, I think there is a lot of architects that claim that, the world has to be messy because it can never be built correctly, for example. I mean, that's one line of argument. In a way, we stand on opposition to that. We want to be stubborn that no, you can actually build things. That the differentiation perhaps between architecture and not architecture is that you can build it precisely and that you can resist the construction industry.
There's another point that might be worth considering. If you look at the poetry of the images and the freedom that it carries, and you look at the control that it takes to implement it, the question is, or which is it actually? Oh, the answer may have to do with who's looking at it. But for you, in order to make it so free, it requires that colossal kind of organizational control.
This is very important. We're not interested in producing perfect figures that look symmetrical, that look perfect, in the conventional Beaux Arts way. We're interested in this ambiguity between something that, when people walk by the pizzeria, they think it's a crazy ceiling. Nobody but us realizes that the plan had to be completely rational in order to build it. So calculated chaos is really what we're interested in. So this is, I think, very important. Exactly.
What it takes to make freedom.
Exactly.
An enormous amount of control.
Exactly. That's exactly what we're interested in.
So which is it?
It's both. It's precisely both. We're interested in the tension between both. I mean, for PS1, we went through great strain to develop two systems that were in contradiction with each other, precisely because if we didn't artificially create a contradiction, it would have been a homogeneous system. And you would have read it as, okay, they're all turning one way. So we had to artificially create this sort of storyline that one layer of sticks responded to one section and the other layer of sticks responding to the other section as a way of creating an internal tension between them, because the program and the context was not given it to us. So it's definitely both for us.
Follow up on that question a little bit. It seems interesting, really interesting to me that it's never a superposition or a juxtaposition of geometries, but always an inflection of one to the other. And I wonder how you study that actually. If you actually study those moments of inflection, which then seem to amplify the pair of multiple geometries, or whether you study it as a composite form and try to reconcile one geometric property with another geometric property. That question is not clear.
Yeah, no, it is clear.
It's like a collage, it has kind of collage tendency
Yes.
to geometry.
Maybe a little bit. It's more montage. I mean, actually, the heart of your question is that we're doing more montage, and how come we're not doing collage? And I think it's a very good question. I mean, that we tend to use geometry as a way of transforming a single material or a single constructional technique, and I think it's a very good question. And I don't know why, to be honest with you, but now, of course, you're making me think. I don't know why we have tended to be obsessed with just one system, almost one system at a time, or one way of translation at a time. There were projects in the past where we would take sort of different sides of a building, and we would apply different logics to each side. And it would, for example, we had a house that we did of terracotta, which comes in different units. So we will use the sort of the brick unit on one side, the tile unit on the roof, and then the garden unit on the front. And we did different manipulations to each of them, and they were more of a collage. But it was the same. It was the same material, even though it was different tectonic units, and they were side by side. They were not superimposed. So I think PS1 is the closest that we come to two different geometries, but they're sort of the same logic anyways. So I think it's a good question. And it might be the next step. I mean, it might be the next step for us. Anyone else?
Which refers to me to an idea about making things very precise to me. And then when you're talking about the plan or the actual model, you refer to the massing of the building as a vacuum packing strategy. So I'm wondering how, when you're making something and then the idea about how to organize it and see are being brought together.
This is where the word alibi for me comes into play. We tend to use organization of the building as an alibi for all the moves, or we try. Does that answer the question or not really?
Kind of. I mean, alibis are interesting. They can be fabricated or strategized.
Mm-hmm. No. We have sometimes. Yes. I mean, I certainly don't think, I mean, neither Nader nor me, certainly we don't think that this is sort of how everybody should work, and we don't think this is the only way of working, and we don't, this is more of a personal, I think of it more as a personal research or a personal stance than a lesson on what architecture should be. I mean, we're stubborn about certain things, but I certainly don't think everybody should be stubborn about them.
But the philosophical implication is that whatever one does is based on an argument which could be argued differently or from a different point of view.
Yes.
Or completely in another way.
Yes.
Which means that every project is, by that definition, ipso facto, an alibi.
Yes.
Or sits on not just yours, but everyone's.
Yes, definitely.
There isn't any intrinsic argument that belongs to the project.
Exactly. Exactly.
Everything is an alibi.
Yes, everything is an alibi, yeah. I mean, once you realize that it could be true or it could be a lie, it becomes simply a technique, it becomes simply a process, and a very personal process. I mean, to say, well, I wanted, in the PS1 project, we wanted the compression members to go from vertical to horizontal, from front to back, because it opens up to, I didn't explain this, but there was supposed to be a music, how do you call it, stand with people, with a DJ and people dancing, so it's supposed to lift up towards the DJ stand. I mean, somebody could argue the opposite. It might not be as good planning, but somebody could argue the opposite. But it's an arbitrary selection, it's an arbitrary move. But the pleasure for us is in taking this arbitrary move and precisely responding to them. That's where pleasure comes in for us.
Sorry, I wasn't generous in my first question. I really appreciate the work very, very much. And I wondered if there was the kind of iconography of geometry that you developed. The material seems to be neutralized in the work. Once the geometry takes up the roles that it does, I wonder if there's a question of work, because there seems to be a work in material interest. And I wonder if you take a material kind of similar role to what geometry does, where the material iconography might have a sustained status culturally, where geometry seems to be slightly fickle. Is that the question?
Yes, it's a question. For us, they're interdependent. I mean, the geometry generally comes from a desire to build it. Meaning we start with the idea that this thing has to be built. And geometry always becomes for us a solution for how to build it. So both the solution to the problem and the problem is constructed within geometry. So for example, for the art center in China, the geometry of having the brick coursings be straight lines that then fan out to produce the distorted walls is intrinsic to the problem of building in brick. The dimension of the pieces is actually a dimension so that you don't have to cut brick. The stretching of the brick is a direct relationship between geometry and material. And sometimes we want them to be in tandem, sometimes we want each other to contradict. We want them to contradict each other, sorry.
It just seems like in all the work, the material is really neutralized at its iconographic level. If you think of the Barcelona Pavilion,
Mm-hmm.
and the material status has, it's communicating at several different kinds of levels. I just wondered, you seem to be very, very accomplished at the level of getting the geometry to have a particular status. And I just wondered if you could take that and not neutralize the material as much as
So it's a strange question for me because until now we've always been asked, well, how come you're so obsessed with materials and not so obsessed with form? So I'm sort of happy that you're thinking that is the opposite. Even though I would disagree. I think that I don't think that we try to neutralize material. Perhaps in hiding or perhaps in contradicting sometimes the way the materials work, it can come across as neutralizing. But for example, we just got a Progressive Architecture Award for the China project, and one of the jurors commented that we had ignored the materiality of the brick. And I was very upset at this, because I said, well, didn't they notice that we're playing with the Flemish bond? Didn't they notice that every move, let's say, every geometric move had a tectonic counterpart in terms of how the brick is assembled? So for us, they really go together. Maybe I didn't stress it as much in this presentation, but they truly, truly go together.
I guess it seems to me that if you care about the performance and the constructability of material and not what it means, that's what I want.
Not that what it means. What do you mean by what it means?
Well, if you look at green marble, which would have all kind of iconographic structure to do with naturalness, to do with certain chthonic aspects of the world.
Okay, I get it. This is a great question. Because actually what we are interested in is creating so many meanings, let's say, for the way that a material is used, that it renders its meaning ambiguous. For example, in the Green Bay project, we went through great extent to have thin, thick, curvilinear, how do you call this thing? Thick windows, thin windows. We went through great extent to precisely blur the differences, because we don't think that that a material really has a single meaning, or it might even mean that a material doesn't mean anything. So by working with multiple interpretations or exacerbating the juxtaposition of possible multiple interpretations, then you bring this issue to the forefront. And maybe that's why it's coming across as neutralizing, which actually I think is interesting. Other questions? Okay. Thank you very much.